Hi, Assalamualaikum. We are from Group 9 for Engineering Mathematics Pbl Group Work. Um, Assalamualaikum to my lecturer, Dr. Nur Hadiza. And I am Tatif Aiman and my other friends, group mates Kamrul Adam, Amirul Haikal and Haikal Amar. And I will go through to introduction. First order ordinary differential equations are a fundamental tool across scientific and engineering disciplines. They capture the derivative of a single variable, providing insight into dynamic processes and solving real-world problems. In engineering, these equations are crucial for analyzing and designing systems such as mechanical systems. They model the relationship between forces, motions, and time, enabling engineers to predict behaviors, determine the stability, and optimize designs. Their versatility makes them essential for understanding and shaping the world we live in.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir bin Johar. I will explain about field table in question A. The question is, water leak from a vertical cylindrical tank through a small hole in its base at a rate proportional to the square root of the volume of water remaining. If the tank initially contains 200 liters and 20 liters leak out during the first day, find when will the tank be half empty? 2. How much water will there after 4 days? The fact is, water leaks from a vertical cylindrical tank through a small hole in its base. Ideas. The reason. First, the tank cannot hold the water pressure. 2. The tank already rusts. 3. Poor quality tank material. 4. The shape of the tank is not suitable. Learning issues. First, why the tank leaks? 2. How to build the questionnaire. 3. What is the type of the question need to ask? 4. How many days the tank will empty? Action plan. Build a questionnaire. 2. Identify the good way to write out the questionnaire by learning material.
And now, I'm going to talk about the pillar table and some explanation about this pillar table for problem B. Let's go through the question first. Zainab works at the mortuary and wants to analyze a corpse. He keeps it cool at a constant temperature of -5 degrees Celsius. Newton's law of cooling states that a body cools at a rate that is proportional to the temperature difference between it and its surroundings. If the temperature of the corpse drops from 36 degrees Celsius to 18 degrees Celsius in 45 minutes, calculate how long it took for the temperature to fall to 6 degrees Celsius and calculate the temperature of the corpse after 2 hours. And now, from the table, we can see the facts. First, time taken for temperature to drop from 36 to 18 degrees Celsius. It took 45 minutes. And second, initial temperature of the corpse, 36 degrees Celsius. And the final temperature is 18 degrees Celsius. The temperature of the surrounding is maintained at -5 Celsius. It means the room itself -5 degrees Celsius. And the ideas, use Newton's law of cooling to calculate the time required for the temperature to reach 6 degrees Celsius. Use the same law to calculate the temperature of the corpse after 2 hours. And what is the learning issues? Applying the formula to calculate and the time and the temperature change. Understanding Newton's laws of cooling and rate of change. The action plan is Newton's law of cooling formula, differentiation of -k times T in bracket T minus initial, where the differentiation is the rate of change of temperature with time. T is the temperature of the body of the surroundings, and K is the proportionality constant. I'm sorry.
Water leaks from a vertical cylindrical tank through a small hole in its base at rate proportional to the square root of the volume of water remaining. If the tank initially contained 200 liter and 20 liter leak out during the first day, find A. When will the tank be half empty? B. How much water will there after 4 days? For the solution, first, we need to identify all the value in the equation. The initial population is 200 liter, and after 1 day, the water decreased to 180 liters. The formula we use to solve the problem A is P times T is equal to initial T times 2 exponent power by constant multiplied time. By using this formula, we need to find the value of K. Enter all the value into the equation. We get 180 equal to 200 exponent power by K times 1. Then move 200 to the left side, so it's become 180 over by 200. Then simplify the equation. Add ln to both sides of the equation to get the value of K only on the left side of the equation. Calculate as usual and you will get the value of K is 0.105. Then use the same formula but use 100 liter for the value of P. It is because the question need P to determine times taken to the tank be half empty. Enter the value of constant. Then we get 100 is equal to 200 exponent power by constant multiplied time. Rearrange and simplify the equation. Add ln to the both side of equation to get the value of K only on the left side of equation. Calculate as usual and you will get the value of time taken to the tank be half empty is 6.601 days. For question B, use the same formula and the same value, but P is the constant. Calculate as usual and you will get the value of water in the tank after 4 days is 131.409 liters.
My name is Muhammad Kamran Adam bin Kamal and I am going to explain question 4. The question is, Zainab works at a mortuary and wants to analyze a corpse. She keeps it cool at a constant temperature of -5 degrees Celsius. Newton's law of cooling states that a body cools at a rate that is proportional to the temperature difference between it and its surroundings. If the temperature of the corpse drops from 36 degrees Celsius to 18 degrees Celsius in 45 minutes, calculate how long it took for the temperature to fall to 6 degrees Celsius and calculate the temperature of the corpse after 2 hours. So the formula is given, which is T equal to Ts plus, open bracket, T0 minus, Ts, close bracket, exponent power by negative KT. So firstly, move the information given. So we will get Ts equal to -5, T0 equal to 36, T45 equal to 18, and Tn equal to 6. Sub of the value of Ts and T0 to the formula given. Then we will get equation 1, which is T equal to -5 plus 41 exponent powered by -45k. Next, we will find the k value first. Sub the T45 to equation 1. 18 equal to -5 plus 41 exponent powered by -45k. Rearrange the equation and we will get ln 23 over 41 equal to -45k ln exponent. Then calculate the value as usual and k is equal to 0.0128. So from the question asks to find the time the corpse temperature fall to 6 degrees Celsius after it dropped from 18 degrees Celsius. Sub the K value to equation 1 to make equation 2. Equation 2 is T equal to negative 5 plus 41 exponent powered by negative 0.0128 T. Then we move the Tn value, which is 6, to equation 2. Then rearrange the equation to get ln 11 over 41 equal to negative 0.0128 T ln exponent. After that, calculate as usual and we'll get Tn is equal to 102.79 minutes. And for another question the question is asking to find the corpse temperature after 2 hours, after 4 to 6 degrees Celsius. First, we will need to know the time from the beginning process. It will be T45 plus 102.79 plus 120 and get T267.79. So we give the value of T267.69 is X. Then sub the time to equation 2 and get negative 5 plus 41 exponent powered by negative 0.0128 times 267.79. Lastly, we will calculate the equation as usual and we will get negative 3.67 degrees Celsius.
I will explain about discussion and conclusion for problem A. In conclusion, the application of first order ordinary differential equation ODEs is widespread and essential in various scientific and engineering fields. This equation describes the relationship between an unknown function and derivative with respect to a single independent variable. The solution to first order E provide value insight into the behavior and dynamics of a wide range of systems. Our key conclusions regarding the application of first order DE are population. Many natural phenomena exhibit growth or decay, and first order DE are employed to describe and understand such processes. For example, population dynamics, radioactive decay, drug observation in pharmacokinetic, and the spread of disease in epidemiology.
And next is the discussion and conclusion for problem E. In conclusion, in Zainab's work at the mortuary, analyzing the cooling behavior of a corpse is crucial for various reasons. There are many reasons to understand this process. She turns to Newton's law of cooling, which provides a scientific framework for studying temperature changes. According to the law, the rate at which a body cools is directly proportional to the temperature difference between the body and its surrounding. By keep the corpse at a constant temperature of negative 5 degrees Celsius, Zainab creates a controlled environment to study its cooling pattern. By applying the principle of Newton's law of cooling, Zainab explores the temperature of the corpse at 36 degrees Celsius to 18 degrees Celsius over 45 minutes. This information allows her to calculate the proportionality constant, which serves a key factor in determining the rate of cooling. Armed with this knowledge, Zainab is now able to make predictions about the cooling process. The temperature to fall to 6 degrees Celsius and projecting the temperature of the corpse after a longer duration, like 2 hours. In order to find the time taken for the temperature to reach at 6 degrees Celsius, Zainab plugs in the appropriate values into the cooling equation and solve her to ascertain the precise time frame required for the corpse to cool to the desired temperature. Similarly, Zainab employs the same method to calculate temperature after 2 hours. In conclusion, Newton's law of cooling proved to be an invaluable tool for Zainab in her work to analyze the corpse cooling process. By deeper understanding of the interplay between the body's temperature and the surrounding environment, through careful calculation and determination of the proportionality constant, Zainab can accurately predict the time it takes and project its future temperature at different time intervals. This knowledge contributes her to work at the mortuary by enhancing her ability to monitor and manage the cooling of corpses, ultimately ensuring the proper preservation of bodies in her care. That's all from me. Thank you.